Have you ever wondered what artificial intelligence really is? In just 3 words, deep learning architecture, the voice of truth is here to explain it to you. Deep learning architecture is a key component in the field of artificial intelligence, AI, and refers to the structure of deep artificial neural networks. These neural networks are inspired by the structure and functioning of the human brain, but are designed to run on computers for machine learning. Here are some key concepts related to deep learning architecture. Layers. Deep neural networks consist of a series of layers. Input passes through an input layer, then through one or more hidden layers, and finally through an output layer. Each layer is composed of one or more artificial neurons. Neurons. Artificial neurons are fundamental computation units in a neural network. Each neuron accepts input, applies an activation function, and produces an output that becomes the input for neurons in subsequent layers. Weights and bias. Each connection between neurons has an associated weight, and often there is a bias term. Weights are adjusted during the learning process to optimize the network's performance. Activation functions. Activation functions are used in neurons to introduce nonlinearity into the network. Examples of activation functions include the sigmoid function, the Rectified Linear Unit, ReLU function, and others. Learning. The learning process in a neural network involves adjusting the weights of connections between neurons. This is done using learning algorithms, such as backpropagation, which seek to minimize the error between the network's predictions and training data. Convolutional neural networks, CNNs, and recurrent neural networks, RNNs. These are subcategories of deep learning architectures specialized for specific tasks. CNNs are often used for image recognition and spatial data processing, while RNNs are used for sequence data, such as speech recognition and natural language processing. Pre-trained architectures. It is often advantageous to use pre-trained neural networks as a starting point for specific tasks. These pre-trained networks have been trained on large datasets and can be further fine-tuned for specific tasks through a process called transfer learning. Architecture choice. The choice of deep learning architecture depends on the type of problem you are trying to solve. There are many different architectures, and selecting the right one can significantly impact the network's performance. Deep neural networks have proven to be powerful tools for a wide range of applications, including image recognition, natural language processing, automatic translation, speech recognition, robotic control, data analysis, and much more. Their ability to automatically extract relevant features from data makes them suitable for handling complex tasks and learning from large datasets.